Hello, this is Mr. Collier, and today we're looking at some trig identities, and specifically some double angle identities and compound angle identities. Okay, so let's look at the IB formula booklet, and here's some double angle identities for sine and cosine. Okay, oops, so we have these two identities here. Sine is pretty straightforward, as you can see. Sine 2 theta equals 2 sine theta cosine theta. But for cosine, you have three different options. Okay, and if you know one of them, you can get the other two by substituting in the sine squared plus cosine squared equals 1 identity. Okay, but you can use them in different cases. You want to pick which one to use. One of the ways would make it easier than the others. Tangent is in a different section, unfortunately, so you got to go to the HL section. And here's the tangent double angle identity. Okay, so we have those identities. We're going to use them now in a couple of examples. In this one here, we have sine A, and you have to figure out tan 2A. So we could draw the triangle and figure out tan A. So if it's sine A is 5 over 13, then we have opposite is 5 and hypotenuse is 13. Using Pythagorean theorem, the other side is 12. Okay, and we're talking about, what quadrant are we in? This quadrant is the third quadrant, only cosine's positive. So tan A is going to be negative, and it's going to be negative 5 over 12. So using the identity that we just talked about, we have tan 2A equals 2 tan A, so it's going to be 2 times negative 5 twelfths over 1 minus tan squared, so negative 5 over 12 squared. I'll simplify by multiplying numerator and denominator by 12 squared. And in the numerator, we're going to get negative 10 times 12. In the denominator, you're going to get 144 minus 25. So that's negative 120 over 119. Okay, next we're going to look at just B here. You might be tempted to use double angle identities right away, but it's much easier to actually square it, and you get sine squared 2 theta plus 2 sine 2 theta cosine 2 theta plus 1 equals 1. Oops, plus cosine 2 theta squared equals 1. But recall, sine squared plus cosine squared equals 1. So you're going to have 1 plus 2 sine 2 theta cosine 2 theta equals 1. So we have 2 sine 2 theta cosine 2 theta equals 1. Now we can actually equals 0 because they cancel. So you can solve now when sine 2 theta equals 0 and when, so you can solve sine 2 theta equals 0, cosine 2 theta equals 0, or you can combine that and solve cosine 4 theta equals 0, right? Because this is a, or sorry, cosine, I mean. Because that's an identity. That equals sine 4 theta. Okay, to do that, first of all, we need the range of 4 theta. So 0 is less than or equal to 4 theta less than 8 pi. So to solve this now, when does sine equal 0? Sine equals 0 here at 0, and then at pi, and then at 2 pi, so multiples of pi. So we say 4 theta equals 0, or pi, 2 pi, 3 pi, all the way up to 7 pi, not including 8 pi, right? So theta equals 0, so we'll divide everything by 4, and we have our answers. Pi over 4, 2 pi over 4, which is pi over 2, and then we got 3 pi over 4, 4 pi over 4, which is just pi, 5 pi over 4, 3 pi over 2, 7 pi over 4 is the final answer, so you have like 8 answers in that one. Okay, next we're going to prove an identity. Let's prove this one here. Now this is not a double angle, obviously, but we can use the identities in our IB formula booklet, the compound angle identities. So let's use this one here. Let me screenshot that. There's the identity for cosine. Notice that there's a negative plus sign there. That means if this is positive, this one's negative. If this one's negative, this one's positive. You use the opposite sign, right? But the way we use that is we can write cosine 3 theta as cosine 2 beta plus beta over cosine beta. So let's just start with the left-hand side and prove we got the right-hand side. So this becomes, now it becomes cosine 2 beta cosine beta minus sine 2 beta sine beta over cosine beta. I'm just going to convert this one first. So we have cosine 2 beta cosine beta minus, that's 2 sine beta cosine beta sine beta over cosine beta. The cosine betas will cancel, and cosine 2 beta, let's look at that formula booklet again. You get to choose for that one, right? But in your question you want sine squared beta, so you probably want to choose this one because that one's got the sine squared in it. So you can write that as 1 minus sine squared beta. This is 2 sine beta, so that's 2. Oh, so there's a 2 over here as well. This is 2 sine squared beta, so the whole thing is 1 minus 4 sine squared beta, which is what we were required to prove. So we're done. Okay, and then the last example, or yeah, the next example we have, let's do this one here. So exact value, you can do this without a calculator because, and this is not in a special triangle, but sine squared minus cosine squared, that is this identity right here. So that's equal to cosine 2 theta. So that is equal to cosine 150. And 150 is, you can get the exact value because this is 150. The reference angle is 30. It's negative there, so that equals negative cosine 30. That is in this special triangle. 30, 60, 90, 1, 2, root 3. So cosine 30 is root 3 over 2. So this is equal to root 3 over 2.